Hello, everyone. The coveted after lunch spot. So I want to start by introducing the company. My name is Brian Ringley. I work at Boston Dynamics. I'm the construction technology manager there, which is basically the product manager for Spot, specifically for construction applications. So most people know Boston Dynamics from our YouTube videos, if you've seen like the robot kicking or the backflips or the dancing more recently. But I like to introduce the three main robots that we're working on. So we have Stretch, which is a warehouse automation robot that we're using to unload trucks, and now because of the logistics issue, unloading some shipping containers as well. We have Atlas, which is the robot that you see dancing, doing backflips, doing parkour. And that's really research into what our leadership calls athletic intelligence. Basically, how far can we push physical machines to behave like human athletes, essentially, and then take the learnings from that, which is the bleeding edge of dynamic robotics, mobility and balance, and then have that filtered down to our commercialized robots. And the first commercialized robot is Spot. And Spot, you can call it, some people call it a robot dog, some people call it a quadruped, it's a four-legged robot. We've got market speak for it, agile mobile robot to distinguish from wheeled mobile robots because it has more agility with the legs than the wheels. And lately we've been framing it as a dynamic sensing platform. It is a tool for you to bring automation dynamically through a human purposed environment rather than statically instrumenting that environment. Here we go. So the way that Spot works is that its body is surrounded by specialized cameras that gives it obstacle avoidance, an amount of depth detection that helps with its autonomy. It's got automation. This is a big part of it, which is how do we take labor hours out of rote tasks and free up skilled labor for other things. So it does that through a 90-minute battery life, and we also have a self-charging dock to extend that, just like drones with base stations. Some of you might be familiar with that. And then we allow people to customize it because just the naked robot doesn't really achieve that much. This is a vehicle or a platform for sensors and for software applications to achieve whatever your use case is. I keep pointing this at the TV instead of at the computer. So again, we need to add something to the robot to create value, to start to build use cases and applications. So we knew we had to bootstrap that a little bit, so we came out with some of our own payload technology, cameras, onboard CPU, customer power and data. We have the arm for mobile manipulation now, which is newer than the base robot itself. But we also knew that we had to maintain compatibility with the things that you already use, taking field devices like 360 cameras, laser scanners, GNSS receivers, and total stations, and allowing you to put those onto this mobility platform to move them autonomously throughout your environment. So there are a couple different ways to control the robot. We knew that if we had the goal of bringing dynamic robots like Spot out of the lab and into the real world, it had to be as easy to use as, say, like a commercial drone, which is basically like a video game with some joysticks. And that's how our tablet works. So when you are in the field with the robot, you have a field tablet. You teach the robot where you want it to go in your environment and what you want it to do. That might be a laser scan, taking a photo, doing a little dance. It doesn't matter. The robot will remember it. That gets recorded. And then you can play that back autonomously as many times as you'd like, right? So the value comes from the frequency and the repetition of that data capture. And the secret sauce and the thing that's like close to my heart is how do you make autonomy work in a dynamic environment like a construction site where that site is changing day after day after day after day. So over the summer, you're gonna have Foster and Partners up here talking about how painful it was to go through our early software, and I'll let them tell that story. But thanks to them, thank you, we have the right insight and customer feedback to build in additional features. So in theory, you want to do the same data capture path, like a daily site walk. I want to take the same 50 photos at the same exact locations at the same time of day, or the same 30 scans every week at the same locations. In theory, you just want that to be the same path every time. In practice, that's not possible on a construction site. Somebody's going to close a door, somebody's going to park a scissor lift. There's going to be an area that's inaccessible because it's going from decking to a poured floor. there's going to be some reality of the job site that keeps you from doing that. So in the latest software now, when you map, when you teach the robot where to go, you do that initial recording on site. Wherever you take the robot, there's an underlying topology. And what that does is that interconnects all possible pathways through that environment. So when inevitably it runs into an obstacle, it will just replan. So you get a preview of the initial plan through your environment, doing the data capture in the order that you want it. You can specify that and edit that. But then the robot will replan itself within certain safe operation parameters as it encounters those obstacles, and it will. Like there is no world in which the robot can do the same path every time, and that's okay. This technology is supposed to come into sites as they are. This is not like warehouse automation where the environment has been prepared for the robot. What is novel about this robot is it goes into human-purposed environments as is and adds value. We're also starting to move from general data capture, which is I just want to take a 360 photograph or a scan of my entire building and then start to quantify progress from that information, to being more aware of certain types of objects. So maybe you're asking a question now. Maybe you're saying specifically, do I have the right number of fire extinguishers, and tell me where they are or tell me if they're in the right place. Are all of my analog gauges within an acceptable range? Are all the heat signatures or all the radiation signatures in my environment within an acceptable range? It's a yes or no question, and that's what you care about, and you get that in near real time from the robot. And we do that with improvements to computer vision, both ones that we've implemented in our own software and also being adaptable with models you might make, models you might even train from the frequency and repeatability of using the robot in your environment, or models you just download off the web because other people are working on them as well. For those models that are then siloed in cloud-based applications as well, we've also given some ability for you to upload those directly to the cloud through the self-charging dock. So we talk about the dock like this is a way to extend the battery life and the power of the robot for longer missions. But the thing that excites me about the dock on a construction site is you're never going to have good Wi-Fi or LTE or anything like that on a construction site. Again, it's not practical. So if you can't constantly be connected to the robot, you can use that dock as a base station. Whether it's wired or wireless, it's at least in a static location with a good connection, which is important because one, you need to tell the robot to start to do something to initiate a mission, and then two, more importantly, you need to grab that data when the robot gets it and upload it. And what I love about that is if you're a stakeholder on the other end of that, and you basically need to review that scan data or review those images, you don't necessarily know or care that there's a robot on the job site. You know that like data is just appearing every 90 minutes. And that's what you care about, right, to keep moving. So I like that the robot starts to fade into the background as we work on this as a whole product solution. We also have something called Scout. So Scout allows you to basically put an on-prem server in your environment for advanced remote operations. So this tends to skew more toward customers in fixed industrial and manufacturing and utilities environments, where they can invest in an infrastructure. It's a little bit tougher to do this on an under construction job site. But the idea is that from your kitchen at home over VPN or from some remote site, you can use human intelligence to drive the robot around to do an inspection. So that's remote operation or teleoperation. Or you can record what you're doing just like you would have done on site with the tablet and then save that as a transferable mission that can be run off of any robot in that environment. This also gives you more access to things like weekly mission scheduling. Maybe you want to run different inspections, different days of the week. And it also opens things up to fleet management, the idea that you might have multiple docks deployed around your environment and multiple robots synchronizing to cover more ground. We also have an SDK, and the point of that is just to let you build whatever you want. For most people, for most of our construction customers, they don't care about this piece. This piece is for our partners like Trimble to build on top of. This is a platform, and they can start to develop construction-specific solutions, which David will talk more about. When we talk about how is Spot actually being used in construction today, I could put like any statistic up here about how bad construction is and what the business problems are. By the way, I started in architecture and construction. I am not a roboticist. I come from this industry, and that's why I joined. I was actually an early customer of Spot and was so excited by what it was able to do on site. I joined the robot side of things. But the big picture for me is you don't know what's going on a job site at any given moment without physically going there, and that's a problem. And if you don't know what's going on in real time, mistakes are made, things get delayed, the site's not staged properly for a trade to come in. Those things, pile up. And if your project is over schedule, it's over budget. So broadly, what are we trying to do? We're trying to increase visibility. That cannot be done and should not be done with people. That should be done with automation. So I also like to phrase, think of Spot as a physical background process, something that's just constantly moving around the site, collecting reality capture so that you have a continuous idea of what's going on that job site. So these are all the other ways that you could solve this problem: people, fixed sensors, and other types of robots, and then the reasons why that doesn't quite make sense. This is also describes about 3 years of my life before I discovered Spot, which was, I cannot find a means of robotic locomotion that is able to traverse my entire job site, that is able to deal with obstacles, material pallets on the ground, temporarily inaccessible areas, stairs, gaps, ramps, et cetera, et cetera. I love drones, by the way, but there are certain limitations to being able to utilize those in interior commercial construction environments. So that's where the strength of Spot really lies, to be able to move. Again, if you think back to the days when the company was owned by Google, when we first started taking larger quadrupeds from earlier research and making them smaller into the form that we have with Spot today, it was entirely premised on fitting through a door and moving up and down typical stairs. We need to bring robots into human-purposed environments. So we're working on two main applications, or our customers are rather, that are really the same thing, but it just depends if you work in BIM or 3D or not at this stage, but I see these things converging. So the first is site progress monitoring, which is basically the daily job walk. Taking photos, pinning those to some floor plan. Here we're showing the HoloBuilder integration, which is called Spot Walk, and then having those points get updated so you have a historical record, right? So this is a very basic job site documentation process that gets automated. And then you can do point in time comparisons, and because of the frequency and the repeatability of the data, you have a cleaner data set from which you can start to leverage AI tools, computer vision tools that all of these apps now have that automatically quantify work in place. Some of our customers, like Brassfield and Gorey, have also used this with 360 video. So this gives you a Google Street View style path that you can kind of jump into, virtually experience the site, and then the denser image frames that you get with video data allow you to do things like photogrammetry for 3D reconstruction. In this case, with drone deploy in combination with drones for full interior-exterior. Digital twin gets more into the 3D space, but also gets more in the real-time synchronization between what's going on in the digital asset and what's going on in the physical environment. So on the right, you're seeing the Trimble Field Link product with Spot that we're going to talk about, or David's going to talk about next. And then on the bottom, you're starting to see tools. This one is a Veer. There are several of them out there competing that start to associate features and point clouds with BIM elements so that reality capture data can actually be ingested by BIM. There are two big problems with BIM and reality capture. One is that BIM was not designed for reality capture. The second is that no one's using BIM. But that's a separate conversation that we can talk about. But we're working toward that end. We have that vision, and that's where the industry is going. So here we have a Swinnerton, again, working with the same tools and starting to realize if scanning is now very easy. Now we can scan every week. What new possibilities does that provide? And that's the thing. Spot is not replacing how data capture was done before. Spot is basically a technology that's allowing you to rethink what you can do with reality capture if it can be done constantly, because it's so cheap and it's easy and it's automated. So when we look at what is the whole product solution here, and this is as a segue into what Trimble is doing with Spot, you can break this down in a number of different ways, but what are the steps? And I don't need to read the text to you, but it's just like 5 steps. They're all highly manual, and all of them need to be solved for there to be value. We feel at Boston Dynamics, we're firmly kind of in the camp of solving the first 3. We're going to give you the software to plan the data capture. We're going to give you the robot to automate the data capture, and then we're going to give you the doc that facilitates, and some software tools that facilitate uploading that as part of the mission at the end of the data capture to whatever cloud location or application you want. But we need partners, we need an application ecosystem to do all of the analysis. We're not going to work on construction-specific AI at Boston Dynamics. We're a robotics company. We're going to create a robust robot platform for a more knowledgeable construction company will stay humble to solve some of those downstream problems that turn data capture into action and insight and value. So with that, I'll turn it over to David.
Thanks, Brian. So I'm David Burczyk. I'm the construction robotics lead at Trimble, and I'm focused on heading up our business area and the integration of the Trimble platform with the Boston Dynamics platform. So as Brian was talking about a year ago, we announced a strategic alliance between Boston Dynamics and Trimble. And the reason for that is that we wanted to merge kind of the expertise that both companies brought into this one common platform to bring robotics out to the job site. And so our kind of underlying vision around this integrated solution that we're working on is really to bring fully autonomous robots out to the job site and become a collaborative robot or a cobot to work side by side with the teams that are on site. Let the teams on site focus on the higher value tasks, and then let these robots come out and start to capture and take over the tasks that might be unsafe or redundant, and allow them to take those jobs over so then the teams on site can really be focused on what are the high priority items that they need to work on. And the value of them bringing this together is that then it starts to improve the overall safety, the quality, and the speed of construction on the job site. And so that kind of became the underlying vision of this co-developed and this collaborative platform between Boston Dynamics and Trimble. So what we've done is we've put together an autonomous field capture module with our software called FieldLink. So this is the application that runs all of our hardware that's being used in the building construction process today. So it's the software that controls our robotic total stations, the 3D laser scanners, and also the GNSS or the global navigation satellite systems that are all used for building construction, from 3D reality capture to just building set out with the total stations. And we've taken the Boston Dynamics platform with Spot and we've integrated that into that application so that now you have one software application that controls multiple hardware devices for all the different types of ways that data capture can be collected on the job site. And so we've brought this together as a co-developed solution to then start to add this as a robotic platform on the job site. So what we developed working with Boston Dynamics is a full turnkey solution. We've put together an application that now is kind of the bare minimum of what you need if you want to bring robotics out onto the job site. So we're taking what Boston Dynamics provides through the Spot platform with the Spot robot. It's the enterprise robot. Their onboard computer called Spot Core, and then also their enhanced autonomy package. And we've merged that with the Trimble solution. So our first integration is using it with 3D laser scanners. And then we're going to start to carry that into also using Spot to work with robotic total stations, and then also be using it with the GPS applications as well. But all this is to provide a turnkey solution so that you're working with one application, one vendor for all your support, your training, and all your needs out on the job site. So if you're not familiar with how you actually operate Spot to start to do this autonomous capture on the job site, the very beginning of it is to go out and define a mission. You need to tell Spot where you want to go out, where you want to capture the data. And so that's the first step of the whole process. And so using the solution, you go through, you take the ruggedized tablet. So we have our own tablet device that works with the Trimble solution. So we have the Spot controls built in. So it's all through a digital joystick kind of interface where this allows you to connect to Spot and you manually control it. So in that application, what you're doing is you're now teaching Spot how to walk the site. So oftentimes there's some confusion out there when people see images of people with the tablet controller operating Spot. They're like, well, it's just a remote control car. Well, essentially what you're doing is you're teaching Spot its path before it can do that autonomous mission. So what you're going to do is you're going to go out on the job site. Oops. Here we go. And you're going to teach Spot where you want it to go and collect this data. So you walk it through the job site, and as you're going along that path, you can define what are called waypoints. And the waypoints are what are areas that you want Spot to perform some type of an action. So depending on what the payload is on the back of Spot, that's the action, or that's the place where an action will take place. So in the case of putting the laser scanner in the back of Spot, everywhere you define a waypoint is where a laser scan is going to be captured. And so you walk Spot along the job site, teaching it this path, it's recording its locations, and then it stores that in its memory. And so once that's stored, then you can run that mission multiple times on a regular basis, or you can schedule it out to be captured on a regular basis as well. So now that you've taught Spot the path, now you can do the autonomous capture piece, where this is where the value of the different types of solutions on the back of Spot come into play. Because if you want this to be an autonomous solution, it needs to be hands-off. You need to take the human out of the equation to where they don't need to be doing different things to monitor the different payloads on the back of Spot. And so this is where, like the laser scanner that we're using, it's called the X7, that's on the back of Spot. It has the ability to do its own automatic calibration, level detection, and then registration of the data in the field. So this, once Spot starts to do that capture, all the registration and the acquisition of the data is happening automatically on the job site. There we go. So once you are ready to do these kind of missions to be repeated over time, you go back into the software, and that mission that you had programmed is stored in Spot's memory. And so you can activate that mission, and then that will have Spot go out and then walk the job site. And so what you're seeing up on the screen is an image of what you'd see on the tablet. So as each individual scan's being captured, it's being registered in real time on that tablet. So as Spot's collecting the mission, each little triangle that you see up on the screen there is a station view or a waypoint where that scan was being captured. And then they're registering as Spot walks along the site. So that by the time it's at the end of its mission, you have a fully registered point cloud. And then once you have this fully registered point cloud, then you're going to start to do different types of in-field workflows. So one of the things that we have built into the FieldLink application is to start to do some real-time analysis while you're on the job site before you've even left. So we have the capability to do like surface analysis. A lot of contractors that are out doing concrete pours, they want to be able to still work that concrete to make sure it's a level plane before it actually sets in place. So we can go out, we can capture laser scans as the concrete's being poured, and we can then run an analysis to determine where the highs and lows are in the slab that's being poured. And then we can also start to do scan to model comparisons. So within the FieldLink application, we can load in the 3D coordination model that's been used for the project. And as those scans start to get captured, they get dropped in place. And we can then start to run an analysis between scan and model and do like a visual deviation analysis to see how the scan is versus what was designed in the model. And then as we have that information collected and it gets fully registered, then we pull it up and we push it up to the cloud because we want to share it out with the project teams. So we have an application called Cloud Engine that then, when Spot comes back to its docking station, whoa, technical glitch. Fast forward here. Yeah. Perfect, thank you. So when Spot comes back to its docking station, then we will automatically pull that registered scan data off of Spot and we'll get it posted up to a location on the cloud. We're using an Azure web server, and then we can automatically notify team members that there's new data to be used for the project. So then you can start to do your design validation pieces. So if you remember with the slides that Brian had, there's those kind of different steps of where things are with the robotic workflow. So we've automated the whole upfront process of capturing the data. We've pushed it up to the cloud. And now the second area of focus is then to start to take this data and start to do something with it. Because what you're starting to see now you have this ability to start to capture data more consistently and more frequently. What do you start to do with that data? So it's opening up new opportunities to provide new insights into what's happening on the job site. So we take that information, we pull it off of Spot, we get it posted up, and then we can start to run design validation. So doing clash detection, showing change over time with cloud-to-cloud comparisons. So scans that are captured on one day can be compared with scans captured on a different day. All that information starts to then feed project information. Where are we at within the schedule? And so that's what's the next area of focus, is to really start to look at those types of applications. So since the docking station becomes such a critical part of this autonomous workflow, it helps to keep all the batteries charged. So then that way you're not having to have any downtime with changing out batteries. We're doing constant research with Boston Dynamics where we're running Spot and we're determining how many scans and how many things can we get collected before we have to go back to that docking station and to sit down. Because then that starts to help with the overall mission planning of when you're collecting the data. And so right now, a lot of applications are using one dock kind of centrally located on a project site. So then how much data can you get captured between charges before you have to come back to that docking station? And then as you start to look at things, you can then start to apply multiple docking stations so you can extend the mission range in the way that you start to capture data. So this is kind of an ongoing area of focus where we start to look at providing some guidance around how does the whole system work as you start to integrate it with the docking station and the different settings as you're capturing data. So then to gather additional information about how we're doing things on a job site and how we're using the different applications, we have a program called the Early Experience Program. So this is where we have the early adopters of the technology, where we start to work with them on actual use cases for how they're using robotics on the job site. So these are 5 use cases that are actual projects working right now with our different customers that have invested into robotics. And it's a little bit of everything where they're using the scanners, they're using the total stations, they're using the GNSS applications. The most common probably use case that you'll see is creating that digital twin, where you have like energy companies, facilities managers, manufacturers of different products. They want to be able to capture what their facility is like or what their plant is like. And they want to have that as that digital twin. So they're using the scan data to create that kind of hybrid digital model where you have a combination of both modeled elements coming from a BIM, or you have the point cloud data that represents the real world conditions. And then they're using that to kind of inform the overall maintenance of the project. They're also using it to document change in different pipes and things of that nature. We have one energy customer where they have over 60,000 miles of pipe that they have to inspect constantly in one of their refineries. And the way they do that today is manually walking the site and just taking photographs. By having the robot go out and start to run that on a more consistent basis, they're actually capturing scan data that they can run analysis off of, and they can start to see deviations and deformities in the pipes they're not visible to the eye, but you can start to see that with the measurement data that comes off. So then that starts to increase their efficiencies to where they can start to identify where there might be potential failures coming in a pipeline, and they can go out, do a manual inspection to see if that is indeed a failure that they need to address immediately, or if it's something that they can wait longer. But it allows them to just be more efficient with their use of time. And then when you start to get away from the scanning side of things, we have a couple customers where they're starting to look at both the GNSS and the total station workflows. So we have one that's using all three integrations that we're working on to start to do like runway maintenance, things like that around airports, where they're taking what they do today with the total stations. They manually go out, document the conditions on the runway, and they would rather put a robot out in those conditions that can do a more consistent data capture. But it's also a safety factor. They don't want to have a person out on an active runway when they can have a robot out there. But then they're also using it to use with scanning to document different conditions, and then also the GNSS, because when you have clear line of sight to the sky, you can start to take advantage of using satellites to help with the positioning of spot on those types of missions. So there's different kind of use cases being used, but these are all active applications. And so one of the things that we're developing is this idea of a remote operator. And so this starts to enable the ability to have multiple robots on different project locations in different geographic locations. And it doesn't allow or doesn't require you as the operator to actually be there physically on site with the robot. So then you start to get efficiencies where you can have a project team based in one centralized location, have robots based in different geographic locations, and then through this remote operator, you have the ability to then remote in and actually control it. And so you have the ability to drive it around manually, make those missions again, or schedule missions and have them run. Or if you're having like a collaboration meeting and a question comes up and says, gosh, we need to go take a look at this one location on the job site and see what's going on there. Well, we can remote into spot, we can get up and we can walk out to that location as if we were on the job site, and we can use the cameras built in to then do that inspection right then and there. So this is a tool that we've developed now. We're getting it rolled out to customers to start doing some applications and testing with it. So what we're doing there is we've got the X7 laser scanner mounted on to do laser scans when we need it to, and then we've added additional cameras that have a higher resolution. So they're pan, tilt, zoom cameras that allow you to go in and do those inspections where you need to zoom in to like maybe a specific label that you need to read. But then you also get a 360 panoramic image to kind of give you awareness of your context as you start to walk around. But this is really starting to open up, how you use these robotics in different locations to where you don't have to be physically on the same job site as the robot. Oops. And then the last slide that I want to go through here is just, what's next and where the future is for what we're doing. So, we've rolled things out now to where we have a commercial application with our laser scanning applications, and then we're starting to do more research into using like the GNSS applications for remote inspections using cameras. This is really popular with a lot of energy companies and contractors that are building solar field arrays out in remote areas. So they don't necessarily have the teams on those sites, and they want to be able to put a robot out there. So using the GNSS, we can teach a path, or we can program in a path just using a series of coordinates. We can download that into the robot, and then with the onboard cameras, we can then go out and do inspections. So one example is like with solar field arrays, they're teaching a path for a spot, downloading coordinates to go up and down each of the rows, and then they're looking for QR codes on the solar panels that are being installed so they can document if those if things have been installed as they have been planned. And then the other application that's really popular is with the total stations. So in building construction today, we're using robotic total stations to take the 3D models that are being used during the design process and then accurately lay out what's in that model out on the job site. So when that kind of technology was introduced, that was really revolutionary because we started to automate a little bit more of that process of accurately taking that 3D data, bring it to the job site. Well, now the contractors that's using that for building set out, they want to take that to the next level where we can start to enable a 24-hour work site. And so using that same kind of technology, use Spot as a platform to then start to do the layout automatically overnight. So that then you come into the job the next day, and all the points that need to be set out from the model have now been laid out overnight, and you come back to the job the next day, and you start to do that installation. So this is kind of the next areas that we're going to be working with. So we're starting to do the integrations into those two products, and we've rolled out now with the commercial application using the laser scanners. So it's a pretty exciting time, lots of different things starting to happen. But that's where we are today, and we're going to continue to focus on these different types of workflows, co-developing the solution with Boston Dynamics. So thank you very much.
Thanks, guys. That was great. Okay, we have time for one question if there are any questions out there. Okay, I'm going to wander down this side, and I'll repeat the question so the guys online can hear. Yes?
Have there been any unintended consequences in terms of interaction between Spot and the operatives on site? How does it work on a practical basis? Are people nice to Spot?
Okay, so just to repeat that, you probably heard anyway, are there any unintended consequences, accidents, I assume, or vandalism on site of operatives and Spot? Are people nice to Spot on site? Is Spot nice to the people?
Yeah, what it does, when Spot comes on the job site, it automatically is a spectacle. So most of what the contractors are doing right now, is they like to do it in the off hours, just so it doesn't distract the crews that are on site trying to get their tasks done for that day. But it's definitely, it draws a crowd. And any new technology, even when I started bringing laser scanners out to the job site, that was a new technology that, drew a crowd because it's something different that you don't see on every day. So from that standpoint, it's, there's a lot of enthusiasm, there's a lot of excitement around it. So I haven't seen anything negative from a robot being on site. There's just a lot of excitement around it. But the main times where we're having to actually do things, we tend to do it in the off hours, just so it doesn't distract from what's being done during the day currently. But as the technology starts to become more integrated and it starts to get used more, the idea is it becomes a tool. And so then suddenly that novelty of this being something new has worn off, and it just becomes part of the workflow where it's seen as a tool as opposed to something unique.
Okay, thanks very much, guys.
All right, thank you. Thank you.